y is equal to tan inverse of ln root x. Find y prime. So we know that d dx of tan inverse of g of x is equal to 1 divided by 1 plus g squared of x times g prime of x. So we need to find g of x. So in this case, g of x is equal to ln root x. But we can rewrite g of x as g of x equals ln x exponent half. Therefore, g of x is equal to 1 over 2 ln x. So what then is g prime of x? G prime of x is equal to 1 over 2x. So we can then put it into the formula. And this becomes 1 divided by 1 plus g of x, which is half ln x. So ln x over 2 all squared, then times g prime of x, which in this case is 1 over 2x. 1 over 2x. So y prime is equal to 1 divided by 1 plus ln x exponent 2 divided by 2 squared is 4, then times 1 over 2x. So y prime is equal to 1 divided by, when you find the LCM, it to give you 4. So 4 plus ln x all squared divided by 4. And y prime is equal to 1 divided by 2x. We'll cancel the 4 2 times. And then 2 can go up. So that becomes 2 divided by x times 4 plus ln x all squared. If sine inverse of x is equal to cos inverse of x, find x. So we know that we can rewrite it as sine inverse of x minus cos inverse of x equals 0. So what we can do is to say let a to be equal to sine inverse of x. Then it implies that sine a is equal to x. So let's draw a right angle triangle. If we draw a right angle triangle, and then so this is a, sine is opposite over hypotenuse. So sine a can be written as x divided by 1. So the opposite in this case is x, and then the hypotenuse is 1. So that's, this side becomes square root of 1 minus x squared. So let's find tan a. Tan a is opposite over adjacent, which becomes x divided by square root of 1 minus x squared. Now let's let b to be equal to cos inverse of x. So it implies that cos b is equal to x. So just as we did for the sine function, let's do for the cos function by drawing a right angle triangle. So b is, so cos is adjacent over hypotenuse. So the adjacent is x and hypotenuse is 1. So that side becomes square root of 1 minus x squared. So we can find tan b. Therefore, tan b opposite over adjacent is equal to square root of 1 minus x squared divided by x. So now let's find tan a minus b. And that from trig identities is tan a minus tan B divided by 1 plus tan A tan B. So this becomes tan A, we got it as x over square root of 1 minus x squared. So minus tan B, and then tan B is square root of 1 minus x squared divided by x, all divided by 1 plus tan A, x over square root of 1 minus x squared, then times tan B, which is square root of 1 minus x squared divided by x. So if we simplify further, you find out that x and x can cancel, and then the square root 2 can also cancel out. So it's left with 1, and 1 plus 1 is 2. Now we can find the LCM at the numerator. So the LCM between root 1 minus x squared and x is x times square root of 1 minus x squared. So this one will cancel out. So we'll be left with x times x, and that will give us x squared minus, then x and x will also cancel out. So we'll come and get into brackets. So let's open a bracket. Root 1 minus x squared, then times square root of 1 minus x squared. And all of this will be multiplied by 2. Remember, we got 2 at the denominator. So there is a times 2 there. So remember that a over b all over c is a over bc. So that will be times 2 at the denominator. So this will give us x squared minus, now square root times square root will go away, so it becomes 1 minus x squared, and divided by 2x, and times square root of 1 minus x squared. So this becomes x squared. Let's expand the bracket, then plus x squared, then minus 1 divided by 2x square root of 1 minus x squared. So now tan A minus B is equal to x squared plus x squared is 2x squared, then minus 1 divided by 2x, then square root of 1 minus x squared. So A minus B is equal to tan inverse of, into bracket, 2x squared minus 1 divided by 2x times 1 minus x squared. Now, but remember that we said that sine inverse of x is minus cos inverse of x is equal to 0. And then we said that A is equal to sine inverse of x, and then B is equal to cos inverse of x. So it implies that sine inverse of x minus cos inverse of x is the A minus B. So therefore, tan inverse of 2x squared minus 1 divided by 2x divided by 1 into bracket root 1 minus x squared is equal to 0. So therefore, 2x squared minus 1 divided by 2x into bracket 1 minus x squared is equal to tan 0. We are finding tan of both sides, and tan 0 is 0. So it becomes 2x squared minus 1 divided by 2x times square root of 1 minus x squared is equal to 0. So this will only be 0 except the numerator is equal to 0, because the denominator cannot be 0, else the function will be undefined. So 2x squared minus 1 is equal to 0, and 2x squared is equal to 1. So x is equal to plus or minus square root of 1 divided by 2. And therefore x is equal to plus or minus root 2 over 2. Prove that tan inverse of x is equal to half cos inverse of 1 minus x squared divided by 1 plus x squared. So now, let x to be equal to tan phi, sorry. And therefore, half cos inverse of 1 minus x squared divided by 1 plus x squared can be written as half then cos inverse of 1 minus x is now tan phi, so tan squared phi divided by 1 plus tan squared phi. But we know that from trig identities, cos squared phi then plus sin squared phi is equal to 1. So if we divide through by cos squared phi, we get 1 plus tan squared phi equals sec squared phi. Also, from trig identities, we know that cos 2 phi is equal to cos squared phi minus sin squared phi. So if we divide through by cos squared phi, and let's divide through, so now we become cos squared phi, and this term to divided by cos squared phi, then that side to divided by cos squared phi. So we are going to get 1 minus tan squared phi equals cos 2 phi divided by cos squared phi. And therefore, half cos inverse of 1 minus tan squared phi divided by 1 plus tan squared phi can also be written as half cos inverse of, now remember that we said 1 minus tan squared phi is cos 2 phi, divided by cos squared phi, all divided by 1 plus tan squared phi, which is sec squared phi. So all divided by sec squared phi. But we know that, so this is equal to cos inverse of cos 2 phi divided by cos squared phi, then divided by 1 divided by cos squared phi, because sec squared phi is 1 divided by cos squared phi. So this is equal to half cos inverse of cos 2 phi divided by cos squared phi, then times cos squared phi. So cos squared phi will cancel cos squared phi. So we will be left with half cos inverse of cos 2 phi divided by 1. So this is equal to half and cos inverse of cos 2 phi. But we know that cos inverse of cos is that angle. So cos inverse of cos x is equal to x. And therefore this becomes half of, then cos inverse of cos 2 phi is 2 phi. So half of 2 phi is just phi. But remember that we say x is equal to tan phi. So therefore phi is equal to tan inverse of x. And that was what we were supposed to prove. So since phi is equal to tan inverse of x, then our proof is right that tan inverse of x is equal to half cos inverse of 1 minus x squared divided by 1 plus x squared. Differentiate into bracket sin inverse of x all squared. So let's let y to be equal to sine inverse of x, but all squared. So y prime, we'll first differentiate what is inside, then we'll differentiate the whole function. So if you differentiate the whole function, you get 2 sine inverse of x. Then you differentiate what is inside, and that will become d dx. So times d dx of sine inverse of x. So now we know that d dx of sine inverse of g of x is equal to 1 divided by square root of 1 minus g squared of x, then times g prime of x. So this will become g of x in this case is equal to x, and g prime of x is equal to 1. So d dx of sine inverse of x is equal to 1 divided by square root of 1 minus g squared, which is x squared, then times g prime of x, which is 1. And that is equal to 1 divided by square root of 1 minus x squared. So we can then take it and put it in y prime. So y prime is equal to 2 sine inverse of x, then times 1 divided by square root of 1 minus x squared. So y prime is equal to 2 sine inverse of x divided by square root of 1 minus x squared.